Now, as our last topic of today, let's discuss about shear stress distribution along G direction. So yeah, this is the front view, and this is X, and this is Y distribution. And if you consider cross-sectional view, yeah, it is yeah, oh no, you have y-axis here and your g-axis here. Okay, so until now what we have done was we considered yeah, this red block for our derivation, and when we consider the force delta H along the x direction, yeah, we consider thickness T and the length along the x direction delta x, and we obtain the delta x over delta H over delta x and tau to obtain tau yx, and from tau xy equals to be tau yx relationship, we discussed about tau xy distribution. Okay, so this is how we derived this expression. However, when you because of the derivation itself, instead of the the tau at specific location of G, yeah, we consider this average stress over the entire plane. So if you consider cross-sectional shape and consider G, yeah, we obtained average stress tau xy, yeah, average when at y position, and that's what our equation only said. Okay, we cannot say which one would be the proper distribution along G direction, like whether it can be uniform, or it can be like a maximum near G equals 0, it will be minimum near G equals 0. Okay, so we don't have idea until now. Okay, so what our textbook says that actually it's the third case where we have a minimum tau xy at G equals 0, and when G becomes in two ends, yeah, the tau becomes maximum. Okay, so this is what our textbook says. Of course, in advanced mechanics course, you can obtain this either by analytical method or computational method. Okay, so actually people have studied the effect of the aspect ratio of the cross section. So when you have the rectangular cross section and consider that the thickness is B and height is H, this is cross section view. So when you have this tall cross section where B is much smaller than H, such that it becomes like a 1-to-4 ratio. It's almost 1-to-4 ratio. Yeah, 1-to-4 ratio is about this much tall. So for this ratio, what we can expect is tau max and tau min has only like a 1% of less than 1% of mismatch compared to average tau. Yeah, this average tau is the tau we obtained from this expression. However, when B becomes almost the same as H, or when you consider this wide distribution, then the distribution of tau is not uniform anymore. The distribution of tau at specific location is really large here and small here, and gradually increasing as it approaches to the free ends. Okay, so the difference becomes almost like a factor of 2 or 100% larger than average, or 20% smaller than average stress. Okay, so this is the case for B over H is about 4. So instead of this fat cross section, if you consider this tall cross section, you don't need to worry about the distribution of tau xy too much, and you can consider tau xy is almost uniform along the g-axis. Okay, so this is the simple discussion I want to have regarding the tau xy distribution along g direction, because our expression it is only about tau xy average over entire g-axis as a function of y. Okay, so regarding the distribution, please have this in your mind, and also remember that when B is like a quarter of H, when we will have this tall cross section, you can assume that tau xy is almost uniform over the entire g direction. Okay, Yeah, so with this, let me finish the first lecture on shearing stress.